Good morning, students. Last time we studied de Broglie model, which is based on the de Broglie hypothesis that the particles also have a dual character like light and radiations. They have a particle character as well as a wave character. For the wave character, de Broglie has given an equation lambda that is equal to h upon p or h upon m into v of a moving particle like electrons. He said that the smaller particles like electrons, protons, etc., they have a sufficient wavelength which can be studied or which can be considerable. To verify the de Broglie equation, that how can we find out the wavelength of a moving particle, he has done. To find out the wavelength of a moving particle, he said if a particle just like an electron is accelerating with a v volt, then its kinetic energy half mv square is equal to E upon v is the charge of electron, v is the volt given for the movement of or acceleration of electron upon 300, because 1 ESU is equal to 300 volts. Now from this equation, v square, the value of v square is equal to 2 EV upon m into 300. If we cut it, then it comes equal to v square is equal to EV upon m into 150, or v is equal to under root EV upon m into 150. Now putting the value of this velocity in de Broglie equation, that is lambda is equal to h upon m into v, the equation becomes lambda is equal to h upon m root m 150 upon root EV, or it can be written as lambda is equal to h under root m into 150 upon under root EV m square. Here it is cancelled, the m cancel, and it equals to lambda is equal to h into under root 1 upon 150 upon EV m. Now putting the value of Planck constant, h, E, charge and the mass of electron in this equation, that is lambda, the value of Planck constant is h is 6.6026 into 10 to the power minus 27 root 150 upon root 9.101 into 10 to the power minus 8 into 4.8 into 10 to the power minus 10 into v volt. It comes equal to lambda is equal to 12.26 into 10 to the power minus 8 upon root v centimeter. Now if an electron, suppose if an electron is accelerate with 100 volts, then the value of v volt is equal to 100, and the wavelength, de Broglie wavelength of an electron comes equal to 1.226 into 10 to the power 1.226 into 10 to the power 10 minus 8 centimeter, or 1.26 angstrom. This value of electron wavelength is similar to the wavelength of X-rays, So we can also say that suppose if the electron is moving with 100 volts, then its waves are quite similar to the X-rays. So by this equation, we can find out the wavelength associated with a moving electron given the v volts. Thank you. Next time we study the deviation and Germer experiment. Thank you.